loud. Okay. Don't make fun of the way I talk.
I was
Fair.
watching what?
You're funny. All right. So the last time we were here, we were starting to talk a little bit about intelligence and how intelligence is measured. We weren't. Okay. Yes, we were there. Okay. So the last time that we were here, we were talking about the development of intelligence tests. And one of the first people to really look at intelligence was Alfred Binet. He is French. And as I mentioned last time, the reason that this intelligence test was developed was because at the time in France, compulsory public schooling for all French children was basically in play. I'm about to sneeze. Hey, shoot. Was in place. So you have a bunch of children that have never been schooled before, and you have no idea of what their capabilities and their intellectual abilities are. You need to figure out the best way to place them into different classes. And so this test was originally designed to be a diagnostic tool to see what kids were capable of and what they were not capable of. And as I mentioned last time, we're focusing on this concept of mental age. So at the age of 7, Binet believed that there are certain things that you should be able to do. And if you were more advanced, your mental age would be higher than your chronological age. If you had some intellectual disabilities or any sort of intellectual deficits, and you could not perform those skills at your age group, your mental age was less than your chronological age. And if you were right on target for your age group, your mental age equaled your chronological age. Now, one of the things that I find really interesting about Binet is that he very much believed that intelligence could be increased through education. Here, and I think this, I don't know if this is specifically something to Western Hemisphere countries or not. We tend to treat intelligence as this innate capability that you either have or you don't. You can't fix it. It never goes up and it never goes down. So here are a couple of examples. You don't need to write these down, but here are some examples of some of the items that Binet expected children to be able to do at different ages. So at the age of 5, you should have been able to copy a square with pen and ink, indicate which of 2 cubes was heavier, and count 4 pennies. By the age of 7, you should be able to copy a diamond with pen and ink, which is a little harder to do than a square, and count 13 pennies. By the age of 9, you should be able to give correct change in a Play Store transaction. So you should be able to do basic addition and subtraction and arrange blocks according to a certain pattern. So these were some of the different things that Binet used in his tests. So over time, this became less of a diagnostic tool and became more of a tool for measuring intelligence in general and not just for diagnostic purposes. It was eventually brought over to the United States and was modified by researchers. And because of that, over time, what was called the Binet was then called the Stanford Binet. So it was developed into the Stanford Binet. Additionally, at the same time, the military is basically requiring all males of a certain age to be conscripted and fight in the Army and armed forces in general, not just the Army. And so they're developing intelligence tests called Army Alpha and Army Beta. And those are basically designed to figure out where to place people. So based on your intelligence levels on this test, you would be placed into certain positions. You probably wouldn't, and I don't know that I necessarily agree with this idea, but the idea was you probably didn't want somebody with a lower intelligence level working in something like intelligence or code breaking or something like that. I don't know that I agree with that idea, but there we have it. Yes.
How does Piaget's law of conservation kind of match into like being able to tell certain things at a certain age, mental age.
I don't know that Benet actually considered things like object permanence and conservation and things like that, because at the time, nobody really knew about those. Benet actually developed this test long before Piaget actually began his work. And so I would like to spend some more time thinking about how they might match up, but it's kind of an issue where one was definitely developed way before the other. Remember that we're still kind of working off of the idea that even though children have differing capabilities and they're growing, we're still treating them like little adults in the late 1800s. Okay, so by the time that the Stanford Binet and the Army Alpha and Army Beta are kind of rolling around, we are starting to change how IQ is calculated. So this was by and large done by the Stanford Binet. And just a reminder, this was originally developed for children. And here's kind of why. So the Stanford Binet basically calculated IQ as your mental age over your chronological age and multiplied it by 100. So this formula works really well with kids. Why would this formula be harder for teenagers or adults? Why would this be harder? Are chronological ages differing? Well, can you go into a little more detail with that, Luca?
The bigger number, so
Well, that's not quite the answer that I'm looking for, but it's hey, it's a good attempt. It's a good attempt. I saw Cora's hand first.
Because adults will have a wide variety of different, just different ways of looking at things. In children, you generally are developing certain things, so therefore you will be developing certain abilities and the skills basically at around the same pace, but it starts differing greatly when you hit preteen and teenagers.
Exactly. So one of the things that we find is that when we are young, the younger that we are, we're generally more alike when we're young than we're different in terms of our processing. But as we age and get more exposure to our respective environments and things like that, we're going to find that we diverge more and more. So to put this into perspective, I'm 39 years old. Some of you are 20. What sort of things should I be able to do that you should not do? I'm pretty sure we're all capable of doing the exact same things at this point, right? Like some of y'all balance a checkbook and I don't know how. And also I don't care to know. That's why I look at my online banking statement at every opportunity. So we all, as we get older, there's not clear norms about what a 25-year-old should do versus what a 50-year-old should do. So we don't have those norms. So what's really interesting, how we calculate IQ now with adults is we do what is called a criterion key. You don't need to write this down, but the idea is we take and pre-test a bunch of questions on a group of adults of varying ages, and we basically get their average. When you take an IQ test, we are comparing your score to the score of the average person. If you are around the average, your score is set to 100. If you do better than other people, your score will be above 100. If you do worse than other people, your score will be below 100. So we're basically doing what's called standardization. And we'll talk about that in a minute. So the Stanford Binet eventually became the Wechsler Adult Intelligence Scale, or the WAIS. So the Stanford Binet developed into a wide variety of tests. So for kids, the Stanford Binet is now basically what is called the WISC, the Wechsler Adult Intelligence Scale for children. There is one for preschool children called the WIPSI. And then for adults, we have the WAIS. And so you will be asked, I kind of talked about this last time, And this kind of goes back to this idea that we're pulling out a common factor on a wide variety of tasks that look nothing like, they don't look like they have anything to do with each other. So with verbal, we get a verbal IQ and we get a performance IQ. So verbal, we get general information. So this would be things like general knowledge. Similarities, where you will be asked about two different concepts and you will be asked about the similarities or the differences between them. I think I gave you an example a while ago on an IQ test that I was given where I was asked, can you compare and contrast restricting something versus forbidding something? And I'm like, ooh, that's tricky. You have to do some arithmetic reasoning, which involves some working memory, vocabulary. You might have reading comprehension and then digit span, where you're given a list of items and you're asked to recall them in a variety of different orders. So I had to recall them in the order that I heard them. I had to recall them backwards. I had to recall them in chronological order, which was the worst. And then we have performance IQ, which is more about things like visuospatial processing. So completing pictures, arranging pictures, doing something called block design. So you're given a figure and a bunch of blocks and you're asked to recreate the pattern as quickly as you can. Object assembly, digit symbol substitution. So the basic idea behind digit symbol is you are basically given a bunch of shapes and each of them corresponds to a different letter. So maybe a triangle is 3, a circle is 4, a square is 5. And then at the bottom of the sheet, you have just long strings of shapes and you're supposed to fill in the numbers as quickly as you can. This is a standard metric of what is called processing speed. So we're trying to see how quickly you can process this information. And then we also have matrices. And at the end of class, I will actually show you an example of matrices. It's basically looking at these different matrices of shapes and trying to complete the pattern. They're actually really cool. I did really well on those. But here's what's kind of interesting. So you get a verbal IQ, you get a performance IQ, and then you get what is called a full scale IQ. So usually if you hear somebody go, my IQ is such and such, they are usually talking about a full scale IQ. Now here's a fun fact that I didn't know until very recently. If your scores are too variable, if your verbal IQ and your performance IQ are significantly different from each other by at least like 25 points or something like that, they can't calculate a full scale IQ because your full scale IQ is basically your average performance. So if you have some variability, the full scale IQ is basically going to make, it's going to take the average and it's going to hide what you're good at and what you're less good at. Yeah, Story. It's common in people that have things like learning disabilities, neurodivergences. So for example, I can't actually tell you what my full scale IQ is because my verbal IQ is very high. Like we're talking maybe about 145, which is a pretty big deal. And then my performance IQ, with the exception of matrices, is like average. So I'm very superior on one, I'm very average on the other. And if you try to take the average of those things, it kind of hides where I'm really proficient and where it's still average, but compared to this high proficiency, it's a struggle. So it's going to, those spiky profiles tend to pop up with things like neurodivergence, different types of learning disabilities, dyslexia, dyscalculia, things like that. And that's one of the reasons that you'd want to look at an IQ test for these things, because it helps you get a better idea of where your strengths and your weaknesses are. Okay, so if you want a good intelligence test, it needs to have these 3 different things. So I've already kind of talked about standardization, and many of you are familiar with standardized tests. I was gonna say, I can't believe how many tests y'all get in high school and middle school and elementary school. We maybe got one a year or one every other year. And I've heard that y'all get like several. Oh, I can't even imagine. Ew. Well, and additionally, your SAT or ACT is also a standardized test. So the idea is that you pre-test a group on these materials, and then you compare those scores to the average. So with IQ, if you're around where most people are, you are considered 100. That's about the average. Most people have an IQ of between 85 and 115. And we'll talk about why that is in a little bit. So we want to make sure that our scores are standardized. The test also needs to be reliable. If I go in and I take an IQ test and I get 115, and then I take it again a couple of weeks later and it's 60, that's a terrible test. It is not reliable. And we need a good test to be reliable. It should yield consistent scores every single time that you take it. And then finally, it needs to be valid. So when we talk about validity, we're talking about does the test measure what it actually says it is going to measure? And that's what we've actually been discovering with things like the SAT or the ACT. In general, it is believed that those originally, we were told that those are measures of collegiate aptitude. So it's about what your ability should be in college. But you know what really correlates very highly with SAT scores? Money. If you have a lot of money, wealth, and educational access, you can afford tutors, you can afford testing programs, you can afford practice exams. I would also add, you can take the SAT more than once because taking those standardized tests is not cheap. I had to take the GRE and it was almost $200 to get for graduate school. I could only afford to take it once. So you better believe I was studying my butt off before I took it. So that would be a case where maybe SAT scores do not actually predict what we believe them to. And what we tend to find is that if you're lucky, SATs, ACTs, they only predict your first semester college grades. And that's only really true if you are generally a part of a privileged group. If you are from a group that has been historically marginalized, the SAT tends to underestimate your abilities and your aptitude for success. So we would say it's probably not a valid test. So we need to have a test be standardized, it needs to be reliable, and it needs to be valid. Now, reliability and validity are kind of tricky, so make sure you know the difference between them. There will be a test question. And here's what I can tell you. If a test is valid, it is going to be reliable. You can have a reliable test without validity, but if a test is valid, it must be reliable. And if you want to learn more about reliability and validity, take my research methods class. We talk about 4 different types of validity. It's fantastic. I like teaching research methods. I don't always think students like to take it, but you learn a lot, even if you don't like it. It's like OChem. You may not like it, but you'll learn something. Okay. Oh, do you need me to go back? Okay. You good? Okay. You don't need to write this down. So one of the things that we know, because of the way that IQ is set up, it actually corresponds to a normal distribution or a bell curve. And folks, the normal distribution, if you haven't had statistics yet, it's really cool. You know why? Because the average equals the median, which is the 50% mark, and it equals the most frequently occurring value. So based on what we know and based on the standardization of IQ tests, it is set up so that the average is 100. That is the mean, that is the average score. It is the median, which means 50% of the population is below 100, 50% of the population is above 100, and it's the mode. It is the most frequently occurring value. If I pick a random person off of the street, they're probably going to have an IQ somewhere between here and here. So we know that IQ is set up so that the average is 100. The standard deviation is 15. So you don't need to know all of this. You don't need to know all of this. This is just me showing off my stats knowledge. So when you're dealing with a normal distribution, 68% of the population will have scores between one standard deviation of the mean. If a standard deviation is 15 points, that means that about 68% of the population has a full scale IQ between 85 and 115. An additional 20, so about 95 to 96% of the population has scores within 2 standard deviations of the mean. So 96% of the population has scores between 70 and 130. So that leaves us with about 2 to 2.5% in the extreme tails that are more than 2 standard deviations beyond the mean. So we have people with severe intellectual deficits. We are talking severely intellectually disabled, and then we're talking extremely high intelligence. So generally what we are going to find is that you don't need to write all of the words, just write some of it. But a valid intelligence test is basically going to divide 2 groups of people into 2 extremes. People who are intellectually disabled with an IQ of 70 or below, and individuals with high intelligence, an IQ of about 130 to 135 or higher. And these 2 groups are significantly different from each other. So yeah, and to kind of give you an example, 145 is 3 standard deviations from the mean. So y'all, this is my verbal score right here. And then here's everything else. I'm very weird. I feel very weird. So if you had to, some of you might have had IQ tests to go into the gifted program. They required it for mine. How about that? And basically they are looking for a particular score cutoff, and it's usually about 130 or higher. So fun story time. I applied to be in the gifted program when I was in kindergarten because I already knew how to read, and I knew how to read very well, and I could do chapter books and stuff like that. They did not put me in the gifted program because my IQ score was not high enough, because I didn't have fine motor skills at the time. So I couldn't write very well, and I couldn't throw and catch a ball. Now I know if you are neurodivergent, sometimes those fine motor skills develop later. So then I tried again 2 years later and ended up getting in, but I don't know. IQ is always so iffy.
I'm very glad that they did not do IQ tests
Mhm.
because I really benefited from some of my like gifted class like teachers.
Yeah, I don't think we actually did anything in our gifted class. We mostly just played video games like Oregon Trail.
My favorite teacher I had was my elementary, okay, I was homeschooled for a long time, so that really limits the pool. But she was my like, I guess, gifted English teacher. And so we didn't spend long with her. It was like 35 minutes a couple times a week, but she really talked about vocabulary and the etymology of words.
Oh,
which has been a benefit to me for the rest of my life, because it's the first time I heard about it, and I was like, oh, this really helps understand these words.
do you have a question, Cora?
No, I just wanted to add on to the conversation.
Uh-huh.
I'm enjoying the conversation.
Oregon Trail.
I'm just hearing this and thinking about all the things I've heard from the people who were in our Gifted Star program at my district.
Uh-huh.
Never positive.
Yeah, I don't think they knew what to do with us.
Well, the thing was, I kind of have kept track of everybody
Uh-huh.
once we got up to high school. I was never put into the gifted program, but I always got advanced scoring and everything.
Uh-huh.
And when we got into high school,
Gifted program stops in high school. You're
Well-
basically encouraged to do honors or advanced
the
placement.
interesting thing was, since I shared classes with them, they did take advanced courses, at least one of them did.
Uh-huh.
The others did not, but one of them did. And I almost always had better grades.
You
which is
know,
an interesting thing.
yeah, Aurora.
Program technically continued into high school, but they called it an IUP.
Okay. So the thing is, and I gotta tell you this too, so people have actually looked and seen what happens with kids that are really, really bright. One of the people that actually looked at this was Louis Terman back in the 1930s. So it's kind of a meme now to be like gifted kid burnout and stuff like that, and like gifted kid burnout and not realizing your potential. And the truth of the matter is that Terman followed up with these kids over a really long period of time. And the truth of the matter is that a lot of them really felt like they didn't live up to the potential that they were told that they have. Like, I don't know. I think I needed to be around people who kind of process things the way I did, but at the same time, I don't know that it gave me any sort of benefit. I don't know.
It's a lot of pressure.
It's a lot of, well, and
I think
that's
it's
the
very
thing.
emblematic of some of the structured schooling system that we have in place, is really wanting to put kids in boxes before boxes even exist.
Mhm. So when we talk about intelligence, we have to consider the genetic components because there are some. So is intelligence nature, or like Bené said, is it something that you can nurture through education and exposure and things like that? And some of you might be like, well, why should we care? Well, I believe that if there is a nurture component to intelligence, we can actually do something about it. We can actually help people meet their potential instead of just being like, here, kids, play with these video games. I will tell you too, one of my cousins tried to sign up and take a Mensa test, which is a club for people with really high IQs. I would never want to be a part of something like Mensa, because it would just be a bunch of people talking about how smart they are. And that's kind of boring. Shh. I'm so smart. I did this. Cool. Okay. So when we talk about genetics and different traits being genetic in nature, here's something kind of important. We have to talk about a concept called heritability. So heritability is kind of critical here. So when we talk about heritability, we are talking about what is going on in the population rather than talking about you as an individual. So when we talk about how much of intelligence is attributable to genetics, we are not talking specifically about you, Anna's genetics, or you, Priscilla's genetics, or so on. We're talking about differences that we see in the entire population. So I want to get that concept out of the way. And we do actually find that there is a significant genetic contribution to intelligence. And we actually know this by looking at twins. So we talked about this way back in chapter 2. If you want to look at genetics, you need to potentially look at identical twins or monozygotic twins versus dizygotic twins or fraternal twins. Identical twins share 100% of the same genes because they came from the same egg. On the other hand, dizygotic twins come from different eggs and thus they share 50% of the same genes, such as just as normal siblings do. Now, what makes dizygotic twins worth studying compared to standard siblings is that dizygotic twins only share 50% of the same genes, but because they're the same age, they tend to be treated the same. On the other hand, with standard order siblings, when one sibling is older and one sibling is younger, you are going to get different environmental experiences. And so it's important to look at a variety of these things. So we do find, if we look at the correlation between IQ scores in twins, we find that there's about a 0.85 correlation for identical twins raised together. Now, that does fall to a little over 0.7 when identical twins are raised apart. So there is some environmental contribution to intelligence. I think that's worth noting. For fraternal twins that are reared together compared to identical twins, it goes from 0.85 down to 0.6. So in that case, that really shows the strong genetic contribution. For siblings reared together, it's actually only about 0.45. So there's much more variability because of differences in environmental treatment and differences in genetics. For unrelated individuals reared together, it's slightly over 0.3. They have a same environment, but different genes. So there are some genetic contributions and some environmental contributions. The genetic contributions seem to carry more weight. And when we look at adoption studies, when we look at kids that are adopted and compare them to their biological their birth parents to their adoptive parents, here's what we find. At the age of 3 years, so we're looking at correlations in verbal ability, children and their birth parents, you can see that the correlations really aren't very big at that point, just because kids really can't demonstrate how intelligent they are at 3 years. I mean, they just don't look like adults. But by the time that you get to adolescence, at that point, children in terms of their cognitive abilities look really adult-like. And what we find is that children have a pretty good correlation to their birth parents, and we find that adopted children have a similar correlation to their birth parents. But what's interesting is that there's not much of a correlation between adopted children and their adoptive parents. So again, we are seeing a significant genetic contribution here. So I want to get back to that concept of heritability. So heritability, so if I gave every single one of us an IQ test right now, would we all get different scores? Yeah, probably. So we're all going to be different from each other. So how much of that variation is due to genetics versus environment? So when we talk about that, we are talking about heritability. So heritability is basically how much of the variation in the population that we see is due to genetics. And it turns out that heredity is basically 50% of the variation that we see in intelligence. So 50% of the variability that you all would have in your IQ scores is due to genetics. But I think there's something really important we're missing here. What about the other 50%? And I think that that's really important here. All right, everybody good? Anybody needs some more time? Okay. I hate that runny nose feeling. It happens to me every morning. Oh. Okay. Oh, did you want me to go back again, Cora? Okay, sorry. Okay, so we do know, and I don't want to spend too much time on this, but we know that groups do differ in their intelligence. And this is where we really need to be careful. So I'm just going to go ahead and put this out there. And I mentioned this last time when we're talking about things like standardized tests and things like that. Remember that these were developed by people who have privilege. And they're often going to value what the privileged people in our culture value. So this means that if you are from a marginalized group that values slightly different things, or you don't have access to these things, you are going to see differences. So we know, for example, that there are some group differences in terms of male performance versus female performance. And again, I don't think this is an actual metric of intelligence. I think it's capturing some aspects of intelligence, but I think it also captures some things that are correlated with intelligence. So we know that different ethnic groups have different intelligence test scores. I would argue that more than likely comes from, again, who is developing these tests and what they value. And I would also say we have to be really careful talking about this stuff because a lot of people will notice those differences and say, well, that's because one group is superior to another, and I will not have that. That is eugenics. That is eugenics, and we do not need that here. So how do we make sense of some of those differences? So here's what we do know. Here's what we know, and I would argue that this is largely due to environment, and I will talk about why. We do know that racial groups differ in their intelligence scores. And unfortunately, some really nasty people have used this information as a way to argue that some groups of people are just naturally better than other people. It was a big controversy when I was in middle school. Somebody by the name of Charles Murray came out with a book called The Bell Curve and basically argued that these racial differences were innate and were marks of superiority and inferiority. And well, I'm just going to say it. He's a gross person. But why I believe that most of this is not due to some innate difference, but rather due to environment is that we know that high scoring people and high scoring groups are more likely to attain high levels of education and income. This is related to access, this is related to wealth and privilege. And historically, some groups have had more wealth, more access, and more privilege than other groups. Yes.
Actually, in one of the studies of the Bell Curve, there was like one group took like the testing was just really, really bad.
Yeah.
Yeah, and so like one group actually didn't they take it like in a different language that they didn't know? Like they took it in English when they were like,
I will have to look that up. I have not read the book, but I've watched long form videos basically debunking the entire book that are like 3 hours long because I love my long form YouTube video essays. I will have to go and take a look at that. We do know some things that are kind of interesting. So if you go to Wales and you actually take the IQ of people in Wales, they actually tend to perform a little bit lower than people who are from England. And that's because when you look at things like digit span, their digits take longer to pronounce than standard 1, 2, 3, 4, and 5. And that actually kind of dampens their IQ score a little bit. Okay, so why would I argue that this is largely environmental? Y'all, you have, in general, human beings, regardless of race and ethnicity, have more in common with each other than not. You are more alike than you are different. In fact, what we find is that in certain cases, you may actually have more in common with somebody of a different race or ethnicity than you do of somebody with your own race or ethnicity, depending on the person. So our genetics are similar. Additionally, we know that there are schooling effects. Countries over in Eastern Asia tend to report higher IQ scores and one of the reasons for this is that they put a bigger emphasis on schooling and education than we do. They go to school on Saturdays. They do not get breaks like we get breaks. Like they get some breaks, but they don't get a lot of breaks. And there are schools that you go to specifically after school so that you can cram for tests. It is called cram school. So they very much value schooling there and education there, and it reflects itself in higher IQ scores. Additionally, IQ scores have been increasing over time. Any gaps that we are finding are appearing to close because from generation to generation, IQ is increasing. This is something that is called the Flynn effect. Now, I will say the Flynn effect has been leveling off with time. So we're not necessarily getting smarter from generation to generation, but odds are pretty good. If I took your grandparents and I gave your grandparents and you an IQ test, you'd do better. And that's not just because of aging effects, just so we're clear. One of the biggest hallmarkers along with similar genetics is that when you give infants tests of intelligence, you don't see these racial gaps, you don't see these ethnic gaps. And so I would argue that whatever is happening is environmental in nature and is probably a product of things like marginalization, oppression, and issues related to privilege. All right, let me see how much time we have. We got 4 minutes. So I'm gonna let you get out early so that we can start fresh on Monday and start talking about what all of y'all have told me that you don't really have a lot of right now. We're gonna talk about motivation, emotion, and actually I'm gonna record for you because on Monday, it's a project work day. So you're gonna get to work on your Choose Your Own Adventure books. I will bring samples. Be ready to work with your group. Be ready to work with your group, bring materials, work on scripting, and I will be recording our first lecture for motivation. Make sure to watch it before class on Wednesday. All right, sound good? All right.